All right, here we are for the pre-calculus chapter 9 review video. Please remember that your test is over 9.1, 9.2, and 9.3. We're going to be light on those topics because we already had a mini test over them, but make sure you review that mini test. And then we'll pick up with 9.5, 9.6, and 9.7. And we will be heavy on those topics of binomial theorem, counting methods, and probability. So I'm going to do some problems out of the book. They're on the exercise review, page 715. So if you want to pause this and go grab your book, that way you can follow along with me at any time. That's where a lot of the problems are going to be coming from. So first problem I want to talk about is a sequence problem. So -1, 2, 7, 14, 23. And this is a sequence problem where I want you to find a formula for any term, the nth term. Now we look at this and it goes up by 3, and then it goes up by, there's the bell, sorry about that. Then it goes up by 5, and then it goes up by 7. It's hard to figure out exactly what this is doing. It's not arithmetic. It's not multiplying. It's not multiplying by the same number over and over and over again. So we have to figure this one out. So this is a tough one. What I want you guys to realize, hopefully, and it might take you some time to realize this one, but this is actually 1 less than n squared. No, I'm sorry. 2 less than n squared. So 1 squared is 1. 1 squared is 1, and 1 minus 2 is -1. 2 squared is 4. 4 minus 2 is 2. 3 squared is 9. 9 minus 2 is 7. 4 squared is 16. 16 minus 2 is 14. 5 squared is 25. 25 minus 2 is 23. So there's the formula. So be ready for some weird ones like that, but just be ready for them. They're not too bad. Make sure you know how to do some basic summation problems like this one. It's the summation from n of 1. And this is going from n to n divided by n plus 1. So make sure you can do this one. This is one that's not arithmetic. It's not geometric. So there's no formula to do this. All you have to do is plug in 1, plug in 2, plug in 3. So if I plug in 1, I get 1/2. Plus plug in 2, I get 2/3. Plus plug in 3, I get 3/4. Plug in 4, I get 4/5. 5, 6, 6, 7s, 7 8s, 8 9s. So there's the first through the 8th term. Add all this together and you will get your answer. So anyway, make sure you know how to do ones that are very easy like that one as well. Also, let's move on to some arithmetic. Remember, arithmetic is the formula for arithmetic is the common difference times n plus our c value. Remember that c value is equal to the first term minus your difference. So that's how you find that. If it's we like to say it's the term that came before the first one if there was one. So there's our formula for any term of an arithmetic sequence. So a typical problem I could give you would be one like this. This is kind of one of my favorite types of problems, where I say that the 7th term is 8 and the 13th term is 6. And I want you to find the formula for any term. So the first thing I got to think of is what's that common difference. So if I'm in the 13th term and I start at the 7th, so to get from the 7th to the 13th term, that would be 6 differences. 6 differences for me to go from the 7th to the 13th. Now, why am I using this? Well, because I know these terms. So the 6th term is, or the 13th term is 6. The 7th term is 8. And add 6 differences. So I'm going to subtract 8. I get -2 equals 6d. Divide by that difference. I'm sorry, divide by 6. What am I talking about? Divide by 6, and I get -1/3 is my common difference. So I'm going to go down a third, down a third, down 1/3, down 1/3, down 1/3, down 1/3. Now the only other thing I need for this formula is c. So I'm going to start off my formula. It is going to be -1/3 times n. But I need that c value. And to find the c value, I need my first term. So I'm going to go back to the drawing board here and think my 7th term is my first term plus 6 differences. Again, to get from 1 to 7, that'd be 6 differences. The 7th term is 8. I don't know what the first term is, but I do know that a common difference is -1/3. I had to figure that out. So that's 8 equals the first term plus -2. Add 2, and I get 10 is the first term. So 10 must be my first term. Hopefully that all makes sense to you. So that means my c value is that first term minus the common difference of negative 1/3. So that's obviously going to make a plus. So it would be 10 and a third. 10 and a third would be my C value, which I don't like really mixed fractions, so I would look at that as 31 thirds. 31 thirds. So my formula would be negative 1/3 n plus 31 thirds. And if you want to check this formula out, you could plug in 7, for example. So negative 1/3 times 7 plus 31 thirds should be 8, and it is. So it's a nice way to plug in 7 and check that out. So that's the kind of problem I like. We did do one like that on your test as well. So check that problem out. It's a good one. Also, we have summation forms. Now remember, the sum of the first n terms of a arithmetic sequence is the number of terms divided by 2. Your first term plus your last term, or the nth term. Now remember, we've said this repeatedly, that first term is not necessarily the first term always. Usually it is, but it's usually best thought of as the first term I care about. So let's do an example here where I do the sum of, let's see here, start with 1, go to 8, so j to 1 to 8, and the formula is 20 minus 3j. Now, is this arithmetic? Yes, it is. Arithmetic is any linear equation. Any linear equation is arithmetic. So I can use the formula here. So let's see here. Okay, 1 to 8 is 8 terms. So that's 8 divided by 2. And the very first term is found by plugging in the first term I care about, right here, 1. If I plug in 1, I get 17. And the last term would be plugging in 8. So if I plug in 8, 3 times 8 is 24. 20 minus 24 is negative 4. So the sum would be 8 divided by 2 is 4. 17 minus 4 is 13. So 4 times 13 is 52, I believe. So my sum would be 52. So notice how I can utilize that summation formula if it is arithmetic. Another problem I want to look at is find the sum of the integers from 20 to 80. So again, find the sum of the integers from 20 to 80. So the integers 20 to 80 would be 20, 21, 22, 23, 24, 25. So that's a very simple formula. The formula for that would be 1n, because you're going up by 1, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, blah, 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 blah. And the formula, the C value would be for this first term, so that would be 19. So if I plug in 1, I get 20 for the first term, and so forth. So anyway, there's going to be how many numbers from 20 to 80? How many numbers from 20 to 80? Well, I like to think of it like this. From 1 to 80, there's 80 numbers. Right? I don't want to care about the first 19 because I want to include 20. Most people will do 80 minus 20 and say, oh, there's 60. No, it's 80 minus 19 because I want to include 20. So there's actually 61 numbers I want to sum up. So it'd be 61 divided by 2. The very first one is 20. And the very last one is 80. So be careful with this one right here. Again, a lot of people just want to do 80 minus 20. You actually want to get rid of 1 through 19, which would leave you with 61 terms left. So 61 divided by 2 is 30 and a half times 100, that's 20 plus 80, is 3,050. So 3,050 is the sum of the integers 20 through 80. So please be careful with that type of problem. That's a good one as well. And moving on, looking at some more, let's look at some geometric, right? Remember the formula for a geometric sequence is your first term times that common ratio raised to the n minus 1. And the common ratio is what you're multiplying by every time. So here's a nice example I found in the book. 54, comma, negative 18, comma, 6, comma, negative 2, dot, 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 dot. So the first thing is, what am I multiplying by every single time? So if you want to figure that out, just divide any two consecutive terms. So negative 18 divided by 54 is negative 1/3. 6 divided by negative 18 is negative 1/3. Negative 2 divided by 6 is negative 1/3. So my common ratio that I'm multiplying by is negative 1/3. Once you have your first term and that ratio, plug them into the formula. And it's pretty easy. So my formula here is 54 times negative 1/3 to the n minus 1. Now you might say, well, wait a minute, don't I have to include the alternating negative, positive, negative thing? That's actually included right here at the negative, because when I plug in a number like 1 for the first term, 1 minus 1 is 0, that's going to make this a 1. It's going to make the first term a positive. Now when I plug in 2, 2 minus 1 is 1, which is odd. It's going to keep that negative, making the second term negative, and then the process would repeat itself. So that's not too bad there. Also make sure you remember the summation for the sum of a geometric sequence, and it is the first term times 1 minus the common ratio to n, which is how many terms you're adding up, divided by 1 minus that common ratio. So make sure you can utilize this as well. I'm going to use a different color here. I like getting things colorful. So an example would be the sum from n equals 1 to 6, and the formula would be something like this: 1/3 to the n minus 1. Now be careful. You don't see a number out here. That probably means that the first term is 1. But anyway, let's just utilize the formula. So once you realize it's geometric is any exponential equation. So arithmetic is any linear equation. Geometric is any exponential equation where the variable n is in the exponent. So let's see here. I'm going to add up 1 through 6. That's the sum of 6 terms. My first term is by plugging in the first value I care about, which is 1. So if I plug in 1, 1 minus 1 is 0. 1/3 to 0 is 1. And let's see here, 1 minus my common ratio of 1/3 raised to the 6 terms I'm going to add up, so 1/3 to the 6. And on the bottom is 1 minus my common ratio of 1/3. So on my calculator, I'm going to do 1 minus 1/3 raised to the 6. And I get some crazy decimal that I don't believe I can change to a fraction. Oh yeah, actually I can change that to a fraction. It was 7/28 over 7/29. Anyway, I'm going to divide that by 1 minus 1/3, which I know in my head is 2/3. So divide that by 2/3. And then I got to times it by 1. And I get the fraction. So it was nice that this one worked out to be a fraction. Sometimes it doesn't. 364 over 243. So make sure you know how to use that formula as well. Not too bad. I'd like to do another one using that formula real quick. The other problem I would like to do using that formula, and I'll grab a different color here for fun here, is the summation of, let's see here, 1 to 20. So n equals 1 all the way to 20. And this is 8 times 6/5 to the n minus 1. So once again, I want to find the sum of 20 terms. 1 through 20 is 20 terms. The first term is found by plugging in 1. That's the number right down here. So 1 minus 1 is 0. 6/5 to the 0 is 0. Or 6/5 to the 0 is 1. 1 times 8 is 8. So there's my first term. 1 minus 6/5 to the 20 terms I'm adding up, and then 1 minus 6/5 by itself on the bottom. So now I'm going to go to my calculator. 1 minus 6/5 raised to the 20, and that number cannot be made a fraction. Divided by, I know that 1 minus 6/5 is negative 1/5. So again, that's 6/6 minus 6/5. Or I'm sorry, 5/5 minus 6/5 is negative 1/5. And I get another fraction or another number that can't be made a fraction, times 8 out in front, and I get 1,493. And I'm going to have to round this off, 0.50, just round to 2 decimals there, 0.50. So make sure you do understand how I'm getting those numbers for the geometric summations. Don't forget, we also do have our formulas for an infinite geometric sum. So if you're trying to find the sum of an infinite geometric summation, remember R has to be between 0 and 1 here. And the form is actually really easy. It's just your first term that you care about divided by 1 minus R. Very easy formula. So let's do one of those real quick. So if I have the formula from n equals 1 to infinity, and the formula is 0.5 raised to the n minus 1. So to find the sum of this infinite sequence, I'm going to first plug in 1. That's right here for my first term. And I get 1 because 1 minus 1 is 0 and anything raised to 0 is 1. And then I'm going to, let's see here. Let's see, on the bottom is 1 minus 1/2. 1 minus 0.5 is 0.5. So I get 1 divided by 0.5. And I get 2. So I get that the infinite sum is 2. And that's because as it gets so big, the numbers on the end don't really make any difference to the sum of being 2. So hopefully that was a nice quick review of arithmetic and geometric sequences. I do want to do a quick example for you of a binomial square theorem. So the example I want to try real quick with you is a minus 3b raised to the 5th. Now the first thing I got to figure out is my coefficients. So I'm going to do this little deal here to understand my coefficients, and this will help me in getting this right. So this is the 0th row, the 1st row, the 2nd row, the 3rd row, the 4th row, and I need the 5th row, so that's be 1, 5, 10, 10, 5, 1. So there's my coefficients. So I know my coefficients are going to be 1, 5, 10, 10, 5, and 1. Now I just got to figure this out. Well, the first term is going to have a coefficient of 1, and it's going to be that first guy a to the 5th. So clean that up. That's a to the 5th. How easy was that? Okay. This next one is going to be a coefficient of 5. It's going to be a, that first guy to the 4th, because he drops a power, and then that negative 3b to the 1st. So remember, I am going to treat this as plus a negative. So that's going to be plus a negative 3b. So let me clean that up now. Negative 3 times 5 is going to be a negative 15. A to the 4th, B. And obviously I can write that as plus and negative. Okay, moving on to this next one. I got a coefficient of 10. Now I got A to the 3rd and the negative 3B squared. Okay, well, this is going to be a little bit more time consuming to clean up. So let's see here. I got to do exponents first. So negative 3 squared is 9. 9 times 10 is 90. A to the 3rd, B to the 2nd. That wasn't too bad. Next one. 10 times A to the 2nd. Negative 3b to the 3rd. Okay, so let's see here. Negative 3 to the 3rd. 3 to the 3rd is 27. That's going to be negative 27 times 10 is going to be negative 270. A squared, b to the 3rd. All right, moving on here. 5, a to the 1st, finally, and negative 3b to the 4th. So exponents first. Negative 3 to the 4th is positive 81. Times 5 is negative 405. I'm sorry, what am I talking about? Positive 405. Again, negative 3 to the 4th is positive 81. 81 times 5 is 405. And that's a, b to the 4th. And then finally, there's no more a's, just negative 3b to the 5th. And that's going to be plus, let's see here, negative 3 to the 5th is negative 243. So it'd be negative 243b to the 5th. Obviously, I can make this plus and negative just a minus. Same thing right here. Same thing right here. So when you have a minus sign right here, it does cause you to go positive, negative, positive, negative, positive, negative. So hopefully that's a quick review of how to do the binomial expansion problems. I think there's going to be a couple of those on your test. Outside of that, please make sure that you do check the problems that deal with counting methods. Hopefully there's no major issues with that. I do want to look at a couple problems in the book here so that you can understand that. For example, look at number 113 in the review. It says there are 10 bicyclists entered into a race, and how many different ways could the top 3 places be decided? Now, because I'm doing the top 3 places, that actually order matters here. So this is actually a permutation, because the order that you finish does matter. So if it goes Tommy, Sally, Kelly, or Sally, Tommy, Kelly, that would be a different order. So order would matter. So this would be 10 riders in the contest, and I'm going to choose. I'm sorry. Well, I'm just going to use I need to use a P. 10 permutation 3, and this would, if you use this on your calculator, it'd be the same answer as you getting. Okay, for first place, there's 10 riders that could go in first, 9 riders that can go in second, and then 8 riders that can go in for third place. This result, 10 times 9 times 8, would be the same thing as 10 permutation 3, and you could use your calculator for that. So be very careful. Another one is a group of potential jurors has been narrowed down to 32 people. And how many ways can the jury of 12 people be selected? So if I want to choose 12 people to be a part of my jury, that would be a combination, because the order that I choose them doesn't really matter as long as I have my 12 people. So that would be one where I have 32 people to choose from, and I'm going to choose 12 of them to be on my jury. So 32 choose 12 is a very large number. Let's see here. 225,792,840. So tremendous options there. So there'll be a couple problems like that on your test as well, where you got to decide, do I need permutations, do I need combinations? Last up is probability, but we've done enough of that in class that I think you guys would be should be okay with probability. Just be careful on problems like that, especially the grid problems we watched. If you haven't watched other probability, please go back and do so. The orangutan and the spider monkey problem with the ands and the or. Make sure you know how to do a problem like that. So hopefully a quick little review there did help you. Apologize if it didn't. If it didn't, make sure you talk to me real quick and we'll get it figured out. All right. Thanks a lot, guys.